Hello. In our last session, I introduced you rational inequations. Generally, I am not of that opinion that one should classify things. But, like the classification of rational inequations has actually come to our help. Now, there could be different type of rational inequations. And those rational inequations are exactly on the similar lines like how we had in case of absolute value. So let us take one by one. First is x minus a, x minus b less than 0. And I take a less than b. Frankly speaking, a and b are some numbers. One is smaller, other is greater. So when I know which one is smaller, I can easily plot it or place it on number line. That is the idea. So when I write x minus a, x minus b less than 0, what comes to my mind? That I have written product of two factors which are less than 0. And one of them must be negative, other should be positive. Like that we have to start. So I start with x minus a negative and x minus b positive. Or I can take it other way, x minus a is positive and x minus b is negative. Now, if I simplify it further, I realize that x is less than a and I get x greater than b. Mind you, please, I have written here and because both the factors, both the conditions what I have written, that x minus a less than 0 and the other one greater than 0, this should happen simultaneously. So other option is x greater than a and less than b. Now if I just say like x less than a, x greater than b, etc., perhaps you may not understand. So I plot it on the number line and I check what is happening. I plot a and b on the number line. A is less than b, so I have plotted it on the left side of b. And then I actually check that where that x lies. If I say x is less than a and x greater than b, that means it should be on the left side of a and on the right side of b. Is it possible? That does not happen. So it is meaningless statement. The other option is x greater than a and less than b perhaps is possible. Some x which is more than a and less than b, that may happen. So our correct part is between a and b, and before a and after b is not of our interest. So solution set is open interval a comma b, means round brackets I have used. Now if I take the second one, which goes exactly on the similar lines, except the fact that instead of less than 0, I have x minus a, x minus b less or equal to 0. So where would be the changes? Changes would be only instead of round bracket, I will have to write close bracket, and wherever I have written less than, I will have to write less or equal to. Where I have written greater than, I will have to write greater or equal to. And I simplified further, and instead of open interval a comma b, my solution set would be closed interval a comma b. Now I go to third type. Third would be x minus a, x minus b greater than 0 as expected. Exactly on the similar lines, so I will start. That one factor should be less than 0, then other one will also have to be less than 0, or both are greater than 0. So x minus a greater than 0, x minus b greater than 0, or x minus a less than 0, x minus b also less than 0. Now this leads to x greater than a and x greater than b, and the second part would be x less than a and x less than b. Now again I do a similar exercise that I will mark on the number line a to b, and then I will check that where the solution lies. Now if I say something is greater than a and also greater than b, then just see the region between a and b. Between a and b, those numbers which fall, they will not satisfy x greater than b condition. So that will have to be rejected. So the only option I am left with is that right side of b I should take. Now second condition if I apply, then I want x less than a and also I want x less than b. Between a and b will not satisfy x less than a. So what I realized that before a there could be part of solution set, and between a and b there is no part of solution set. So my solution set would be either in the less than a region or in the greater than b region. So solution set would be called as minus infinity to minus a union b to infinity. I go to next. That is x minus a, x minus b greater or equal to 0. Now what would be the corrections which will have to be made? That instead of less than, I will have to write less or equal to. Instead of greater than, I will have to write greater or equal to. And instead of round brackets, I will have to write close brackets. And my solution set will turn out to be minus infinity to a closed, that is square bracket, union closed b to infinity. So we have now 4 types and their 4 solutions. So let us have a quick glance. And I realize that x minus a, x minus b less than 0, the solution is open interval a comma b, x minus a, x minus b less or equal to 0, closed interval a comma b. Third type is x minus a, x minus b greater or equal to 0. Then the solution set would be before a or after b, that is open intervals union. And the fourth type is x minus a, x minus b greater or equal to 0. And the solution set would be minus infinity a close union close b to infinity. So in this session, we have classified the standard types into 4 inequations, and most of the time, whatever inequations you get, they would fall in one of the categories, and we know then how to write the solution. Mind you, please, this session was only for the derivation. We will not be writing solutions exactly based on the derivations, but the final answers, just now what we have seen, those final answers are to be written in the interval form. So, in the next sessions, we will have illustrations. Till then, stay tuned. Thank you.